Hi, class. So I said I was going to go over the midterm stuff, and I realized I put it off a bit, so I need to get it done. I'm going to concentrate on the part B. If you have questions about part A, send me an email or schedule office hours, and you can talk about the individual things there. I think this part, though, I want to focus on part B because it had uh, I think the most useful concepts that you need. I mean, this was on both of the tests really, but this practical version kind of reinforced the most important things I think you need to get. So, starting with this first question, um, this relationship between vehicle and service. So, vehicle receives a service. Now, when you're talking about business rules, a lot of these tests questions that we have are sort of reversed. So you're being asked to do on a lot of these things is to take a middle kind of step in the process of creating a database and divine what the previous steps must have been. So in this case, usually you start with business rules. You go interview some people, like say they hire you to build their database. You have to figure out how everything works and what they're interested in, what kind of questions they want to ask the data to get information out. And you'll build a model for how you'll identify the entities in the organization and how they're related to each other and what attributes each thing has. And then you'll build the business rules. So that's the first step. This step would come after where you build the ERD from the business rules. So you're given an ERD, an entity relationship diagram, and you're asked to give what the business rules must be. And whenever you're doing this, try to stay within the diagram because you can't really necessarily, there's a little bit of speculation you can do sometimes, but most of the time you have to go by what is being indicated by the diagram. So in this case, if you look at vehicle and service, you've got this kind of thing. First of all, it's many to many. So this is the reason why I have a little inset video of me, because I want to do some gestures here. So if you think about these, the crow's feet, right? This is the mini side of a relationship. This is the kind of thing you've got going on. And you can have this indicated this way in a relationship, an entity relationship diagram. But when it comes time to put it in the database management system like Access or Oracle, which you just started using, or any of the major relational databases, you can't put it in directly like this. You can do this in a network diagram. You can have many-to-many relationships modeled in a network database, which is another kind of a little bit older database than entity relationship. The thing about entity relationship is because of the mathematics behind it, which I won't try to get too much into. That's like an advanced database class, but it minimizes the problems you have with anomalies in your data. That's the reason why they were chosen to be used once they were developed, because it reduced problems you would have, made your data cleaner. Often a little bit of tangent, but it's good to know why you're doing these things. But because of mathematical reasons we won't get into, you can't directly put many-to-many relationships into a database management system. All your relationships have to be one-to-one or one-to-many. Any other examples or exceptions to that? I don't believe so. At least almost 100% of relationships you put into a database are going to be one-to-one or one-to-many, 1 to X. So you'll always have a one side. So with this is many-to-many. And the business rules, if we look at it, one thing to do is look at this relationship. And the way to interpret is the thing at the elbow, this thing on the hand, the fingers, tells you how the thing at the elbow relates to the thing on the other side. And in other words, it'll tell you whether or not it's necessary that thing is related to the other thing on the other side, and how much it is. Like the cardinality is how many instances of each thing on the right are associated with the thing on the left. In this case, that's the way I'm looking. I'm looking at service to vehicle here. I think I'll just tell you what the rules are here, and then maybe you can see how it works. So let's just look at vehicle to service first. So ignore the little blue circle and the and the crow's foot on the vehicle side, and just take that middle line and think of that as a 1. And what you're saying is that each vehicle must have 1 or more services. So it's must have because that vehicle, you go to the other side and you see that line that goes straight down next to service. That means mandatory. That's called that's the participation of the left thing to the right thing. In this case, because we're going from vehicle to service. So the participation of the vehicle is mandatory in the service. That's why you have that line. So at least one, if the vehicle is involved in this enterprise at all, it will get at least 1 service. And if you think about it logically, it kind of makes sense. You're not going to take your vehicle into the shop, in theory, at least as far as this database is concerned, unless it's getting a service. Because you're not going to take your vehicle in for no service, right? It doesn't make any sense. So that's why it's mandatory. And you can get an oil change and a tire rotation, right? You don't have to just get an oil change. So that's why it's a crow's foot on the service. You can have many services when you go in. But you're going to at least get 1, or otherwise you don't come in. So, and again, that's relating it back to real life, but from the diagram we can determine that because it does say that it's mandatory. So you can think about it. What makes common sense? Well, you bring this vehicle in for service, you're going to get at least 1 service. You at least get an oil change or a tire rotation or a alignment adjustment or whatever, right? So that's why it's mandatory. Now, if you ask the question, so each vehicle will receive 1 or more services. Now, that's the first rule. And notice how I used each. If you start with each or all or whatever, it works better for formulating it in a formal way. So each vehicle receives 1 or more services. It must receive at least 1. Now flip around the other side, services. A service will be applied. I use the word applied to, is received by. You can, whenever you have the receives, the verb in the middle, you can always do active. Usually you can do active, passive, right? So if a vehicle receives a service, then a service is received by a vehicle. So that's how the 2 directions can go with your relationships. So so a service is received by 0 or more vehicles. So that go in this direction, you see the O, that stands for optional. I think of it as a 0. That kind of helps me sometimes, but it could also stand for optional. It's optional participation. So in this enterprise, and the way I described it with some students and stuff is imagine you have the $1 million cleaning service as one of your services that you give to vehicles. It's possible that whoever brings the car in and gets that at least 1 service, right, oil change or whatever, might not ever opt to have that service as well, the $1 million. They can't, like, nobody is going to spend $1 million to get their car clean. I'm making up a scenario, right? But it's possible that you have a list of services that no one ever takes. Another way of looking at it is it's the first day that you've ever been open. You got your database, right? Car comes in, you put that vehicle in the database, and the only thing that car gets is an oil change. So that means that if it were mandatory on both sides, the vehicle would have to get, every vehicle came in would have to always get all the services. Does that make sense? Yeah, because if it's mandatory on this side, a service is received by 1 or more vehicles, and definitely 1. I mean, that means that first day you'd have to get all the services, because at least the vehicle would have to get, like, the service side would have to be participating on the vehicle side at least once. So if you can see, this gives you the option with the optional to not give every service to every vehicle. And it makes more sense if you think about it over time. On the first day that you come in, the car has to get at least 1 service. We know that from the diagram, right? But if it was mandatory the other way, we'd have to say that every service has to be applied at least once to some car. But if there's only 1 car, then all of them have to be applied to that first car, because there's no other cars to apply the other ones to. I know it's confusing probably, but if you just boil it down, so each service, let's put it this way, this is the other rule. Each service is received by 0 or more vehicles. So every vehicle that comes in could get an oil change, right? So that's more than one vehicle on that side. But it's possible that like super deluxe service is never purchased by anybody, so it doesn't get applied to any vehicles. I hope that makes sense. Now, converting this to ER diagram, you don't always have to do this, but it's usually a good idea. It's a stepping stone. So you start with the ER diagram that has a many-to-many relationship like this. This is where I do the signs, right? So each side has a crow's foot on it. One stepping stone to get it to where you put it in a DBMS, like Access or whatever, is to model it with an ER diagram that includes getting rid of this, because you can't have this directly into the DBMS. You can have it in your diagram all day, that's fine. But you can also convert your diagram stepping stone wise, the next step to get it towards where you can put it in the actual database management system, the DBMS. And the way you do this, and this is why I'm doing this video with my little picture, is that whenever you convert a many-to-many relationship to 2 one-to-many relationships with a new entity in the middle, you do this. Just take your arms like they're crossed here and pull them apart. And the 2 minis should be on the new thing. The new thing should have the mini side on it. And the 1 should be on the old things that used to be many to many. So the vehicle will have a 1 on it, and the service will have a 1 on it. We'll just have a line with the crow's foot like this. The mandatory and optional we'll get to. I'll do this first. So where you just have a chicken leg holding, like, think of it as the new thing's a box that you're holding with your fingers like this. Just get that set up first and then decide what's mandatory and optional. But remember this, whenever you're converting many to 2 one-to-manys with a bridge entity or junction table or whatever you want to call the thing in the middle, do this motion and you've got it. The reason why I'm telling you this and why I'm making this explicit is like making a big deal out of it is because I've seen so many people kind of get it right, but then they do something like this, right? Where the thing in the middle is one or both are pointing in the wrong direction. It's always the new thing gets the minis. So you've seen this in the past. Where you've experienced this is TBL config, right? Many pieces of hardware can have many pieces of software installed on them, and many pieces of software can be installed on many machines. It's many, right? But the way you see which machines have which software, like words on machine 1, 2, and 7, or whatever, that kind of thing, is the table config, TBL config, or config, if you just want to forget about the prefix part that just says, that says it's just a table and Access. So the way you make this diagram, and I use the draw IO, is like this. This is the right answer for the test. There are other answers that were possible that could also be correct, because in a way, in my opinion, this is not sufficient. But it's correct enough. So what you do, here's where we spread them apart, right? We spread apart and we put this new thing in between called vehicle service. And you see how many side is on this side, many side is on this side. Now you see the optional and mandatory stuff. We'll get to that. And what you do is you take the primary key from each of these the original tables, the original entities, and you include them as foreign keys in the new one, the new entity. The default name is first one side of the table underscore the other side of the table's name. So vehicle underscore service. Sometimes you can make up a new name in the middle here that makes sense. I can't think of a good one for this one, like servicing job, maybe something like that. Job, you could call it job. I've got servicing in a different diagram that I'm going to show you. But anyway, so what you do is you have the foreign key, but notice this is a composite primary key. So whenever you have and this is a crow's foot diagram. This is what they look like. They have the crow's foot relationships. Technically, I should put, a verb here. So I kind of left that out. You should put it in yours. So a vehicle receives a vehicle service, and a service is applied to a vehicle service. You can another thing to think of this is like this is an itemized, this is a line item on an invoice kind of too. That's another common typical thing for these bridge entities that you create between two tables. But also you'll notice that the attributes are just listed inside the box, and then they're labeled whether they're a primary key or foreign key or whatever. And so you notice this is neither a primary key or foreign key. It's the service date. You only know what the service date is when you know these two things. Okay, so what this is saying is that a certain vehicle, say vehicle number 1, so PK number 1, gets service number 2, maybe. So that's an event that happens. The only problem with this particular scenario is that each vehicle that comes in will only get whatever service it gets once. It can come in another day and get a different service, but because the primary key is the combination of the vehicle ID and the service type, the primary key only allows you, it allows each vehicle that comes in, say I'll take my car in and get an oil change. I can never get an oil change again and have it recorded in here with entity integrity. So that's if you notice that, that's good. I didn't expect you to get that far on it. I mean, we can't, as a matter of fact, we can't necessarily know that that's not the business rule. It could be like you're only able to ever get each service only once. That could be the business rule based on the diagram. And the diagram just said get rid of the many-to-many relationship. So if you do this, you're fine. You could, if you wanted to, combine the service date possibly with the other two primary keys. Notice it's not a foreign key, because a foreign key means a foreign key is a key in a table that is a primary key in another table. And notice the foreign key always goes on the many side. If there is a many side, it's possible it's a one-to-one, and in which case, it would be on the one side because there's only ones. But typically, it's going to be a one-to-many relationship. Most relationships are. So the foreign key is always going to be on the many side. So what we're saying is we take the car number 1 comes in, gets service number 2, combine 1 and 2, and you've uniquely identified that row, and then you add the date. Later on, we'll find out why date's here instead of here or here. But I'll tell you really quickly the reason why is you don't know what date it is for the car or the service unless you know both things at the same time. So if you come in on January 1st to get an oil change, and then you come in on January 2nd with the same car to get tire rotation, that's 2 different events, and you have to know both of those things to know which date it was. You could, to make this unique, include the service date in as well, I think. So you would have the oil change for car number 1 on January 1st, and then a tire rotation for car number 1 on January 1st. If you take all 3 of these together, so in other words, the way to change this is to move this up here and make it a PK, but it won't be a foreign key because it only exists in this table. And then you would combine all 3 to make the primary key. Alternatively, let's see if I still got it in my clipboard, because yeah, I do. Great. You could make a surrogate key, and that would solve the problem that I'm talking about, which again is a subtle problem, and you didn't have to get this right on the midterm, but it wasn't wrong if you did this one, which is a lot of people who did the right version got this and understood it. But if you ask, like, if you think about it, if you get an oil change on January 1st and January 2nd, it's not unique, right? Because if you just go with the vehicle ID number 1 and the service type number 2, it's not entity integrity. So I would just use this, and typically, unless you have a really good reason not to do it, it depends. It's an art, but a lot of times your bridge entities will just have a surrogate key anyway. So you notice now these are demoted to just foreign keys, so they're not combined or anything. They're not a composite primary key. They're just foreign keys that tell you that servicing ID number 1 was vehicle 1 who got oil change, which is number 2 on January 1st. And then servicing ID number 2 was vehicle 1 who got tire rotation, which is service 3 maybe on January 1st. So you can see how you can make it unique, because you just start at, usually the way these surrogate keys work is you just start with number 1, number 2, or maybe 1000, 1001, or whatever. And you just keep incrementing as you add new rows to the table. I hope that makes, so both of these are right. I think this is superior for what really would happen in real life, because again, you couldn't get an oil change with a certain car ever more than once in this database and still have entity integrity, have a unique primary key that's a combination of these 2. But this is the way. This is where you would start. Okay, if I just combine these 2 primary keys as foreign keys in here, combine them together, that make a new composite primary key. Remember that composite primary key, because when we talk about second normal form coming up soon, when we talk about normalization, that's what it all has to do with. It has to do with this scenario right here. Okay, I'm going to stop there because I knew this would take a little while to... oh, no, I'm not going to start there because we need to talk about participation. So just modeling that participation thing, you notice that this is mandatory still, because if you bring a vehicle in to get a service, it's going to have it's going to be entered into that middle table at least once. So you bring in car number 1 to get a service. You don't know which service you're going to get. It could be any of them, but you're going to have vehicle 1 on that line. And then over here, there's service types you might not ever have in this middle thing, because again, like it's the super deluxe $1 million cleaning service or whatever. You might not ever have that PK as a foreign key over here because nobody ever got it. So that's why it's optional here. But it's mandatory here because if you bring a car in for a service, it has to get at least 1. So every line in that middle table is going to have both foreign keys, whether you do this scenario or not. It's still going to have, it's mandatory that one of these service types be in this middle one. Whether, as a part of the primary key, as a second, foreign key that's a composite primary key part, or whether it's just the foreign key. But you have to, for every row of this vehicle service table, there will be a primary key from a car and a primary key from one of the services. And again, maybe a certain service never gets used, but it'll be one. It'll be, maybe it's oil change. Everybody that comes in and they only get oil changes, so it'll be service, I think I called it number 2, all the way down for that foreign key for service type in the middle table. But you have to have something for the service type there. And that was true in the original if we look at it. Right, vehicle comes in. Can you really see that here? Actually, you can't really see it as easily, but it's something, because every vehicle comes in and must get at least 1 service. So it's really that right there. It's sort of like that and that and this. That and that sort of kind of merge together if you think about it. I'm going to have to stop and think about it, but I hope this makes sense. Anyway, that's that first problem. And I'm going to cut this up into parts. So maybe this is the only one you had questions about. So I guess stay tuned for a couple of the other questions. I might not do every question on the part B, but I'll do a couple anyway.